last 30 years, NASA has been exploring Mars. And in that exploration, we're looking for signs of life, we're looking for water. And a year ago, we found a sample. Again, we're exploring in places where there were rivers and where there were lakes. And much as on Earth, we think that that's where we'd see signs of ancient life on Mars. And so a year ago, we thought we found what we believe to be signs of microbial life on the Mars surface. This very well could be the clearest sign of life that we've ever found on Mars.
What if NASA just did it? What if after decades of sifting through red dust and ancient rocks, the agency finally found the first real clues that life once thrived on Mars? That's not a sci-fi teaser. It's the tantalizing question raised by NASA's latest briefing, where officials hinted that a year-long investigation has turned up the clearest sign yet that Mars was once alive. This video dives into that announcement. Over the next few minutes, we'll take you inside the rover's findings, explain why this rock is unlike any other stone on Mars, unpack the science behind the biosignature claim, and show you how the discovery fits into NASA's grand plan to turn humanity into a multi-planet species. We'll also explore how this news connects to the Artemis program and the wider search for life in our galaxy. So buckle up, we're going to Mars and beyond. To understand why this rock is rocking the scientific world, you have to appreciate the long, frustrating road to this moment. NASA has been exploring Mars for more than 30 years, systematically searching for evidence that the red planet was ever habitable. Over those decades, the agency has announced several possible signs of past life, only to have the scientific community show they could be explained by non-biological chemistry. That skeptical back and forth is healthy. It's how science protects us from wishful thinking. As NASA Administrator Bill Nelson recounted, the agency found a promising sample a year ago while exploring ancient riverbeds and lakebeds with the Perseverance rover. Scientists across the world were invited to pressure test the data, hunting for alternative explanations. After 12 months of scrutiny, the reviewers admitted they couldn't find a non-biological source for what NASA was seeing. That's why this announcement is a big deal. It doesn't claim proof, but it does elevate the evidence from curious to compelling. During those 3 decades of exploration, the agency has deployed orbiters, landers, and rovers to build a layered understanding of Mars. Last summer, while roving along a dried-up river channel in Jezero Crater, Perseverance stopped at a light-colored outcrop dubbed Bright Angel. Embedded in that mudstone were dark poppy seed-like specks and ringed leopard spots that immediately caught the team's attention. These features are tiny, smaller than a fingernail, but they told geologists that something unusual happened as the mud was laid down billions of years ago. To get a closer look, engineers extended the rover's robotic arm, drilled a core sample, and trained 2 sophisticated instruments on the rock. The Sherlock instrument used a laser to produce Raman spectra and spotted a distinct G-band signature, a chemical fingerprint that on Earth almost always points to the presence of organic matter. The Pixel instrument then mapped the elements within the rock and found that the spot's dark rims were rich in iron and phosphorus, while their cores contained iron and sulfur. Those minerals matched vivianite and greigite, compounds that on Earth are famously produced as byproducts of microbial metabolism. In short, the rock is a rusty red mudstone laced with organics and minerals that look exactly like residues left when microbes feast on organic carbon. To appreciate why these odd textures are so meaningful, it helps to picture the landscape Perseverance has been driving through. In its first 4 years, the rover traversed 3 distinct terrains: an igneous crater floor where magma once cooled, a western delta made of sedimentary layers deposited by a long-lived river and lake, and a margin unit rich in carbonates. After these campaigns, it rolled into Neretva Vallis, a river valley carved more than 3.5 billion years ago by torrents of water that carried mud, sand, and gravel into Jezero. Where that energetic river met a tranquil lake, fine sediment settled from suspension, recording the transition from flowing water to calm basin. the Bright Angel outcrop sits at the northern edge of that ancient channel. After abrasion to remove surface dust, the team imaged the rock in microscopic detail and panned across it with spectrometers. The Sherlock Instruments Raman and fluorescence spectrometer detected that crucial G-band signature, suggesting the presence of aromatic carbon chains bound in the mud. Pixel then created an elemental heat map, revealing concentrations of iron, phosphorus, and sulfur in the spots. On Earth, microbes alter their environment as they eat. Iron-reducing bacteria leave iron phosphates, while sulfate-reducing microbes precipitate iron sulfides. The same pattern appears in Bright Angel. That correlation doesn't prove microbes were there, but it's exactly what astrobiologists predicted they should look for when devising Perseverance's payload over a decade ago. Every sensor on the rover, from cameras to spectrometers, contributed a piece of the puzzle. Nikki Fox, NASA's Associate Administrator for Science, framed the discovery bluntly. These leopard spots may be the closest we've come to discovering ancient life on Mars. They are not life itself. Nothing is wriggling inside that rock. Instead, they are biosignatures, telltale textures and chemical patterns that hint life might have been involved. Fox likened them to leftover fossils or excreted material from microbes, the equivalent of seeing leftover fossils, leftovers from a meal. Maybe that meal has been excreted by a microbe. Crucially, the features would have formed billions of years ago, when the river delta was a calm lake bed. That timing overlaps the era when life was first emerging on Earth. If microbial life arose on both planets at roughly the same epoch, it strengthens theories that biology springs up wherever conditions are right. Jezero Crater was chosen for exactly this reason. The site exposes some of the oldest rocks anywhere in the solar system, older than many rocks on our own planet. The sediments there formed in a lake, meaning they were laid down in water. Before this press conference, reviewers tried to show the leopard spots were mundane iron deposits. They couldn't. Still, Dr. Joel Hirowitz, the lead author of the Nature paper describing the find, emphasizes that until the sample is tested in laboratories on Earth, we cannot completely rule out non-biological origins. NASA's answer is to bring the rock home. The Perseverance rover drilled a core from this outcrop and sealed it in a titanium tube. Now the agency is evaluating plans to retrieve those samples, balancing budgets and technologies to get them back as quickly as possible. Only under a microscope on Earth can scientists confirm whether the structures were built by ancient microbes or merely by mineral chemistry. That humility reflects the scientific process at its best. The story of the leopard spots began with a press briefing last year, but NASA didn't rush to declare victory. Instead, the rover collected more data. The team spent months aggregating and interrogating those measurements, and then they wrote a comprehensive paper that had to survive anonymous peer review. Only after external experts agreed that the biosignature interpretation was plausible did NASA decide to share the results with the world.
So what do you think? Are those leopard spots the fossilized fingerprints of microbes that died billions of years ago? Or are they another lesson in how chemistry can mimic biology? We're on the cusp of answers that could change everything. As NASA prepares to return these precious samples and other missions hunt for life in far-flung oceans and exoplanets, the question, are we alone, has never felt more immediate. If you want to follow this unfolding story, if you want to be among the first to know when that Martian core finally gives up its secrets, make sure you don't miss our updates. Subscribe, hit the notification bell, and let's explore the universe together.